Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Alrighty, welcome to the latest episode of Lunch with Tech Leaders. My name is Jason Brown. I'm a cloud solutions architect with Right Brain Networks, and I'm your host for today. Joining me is software and data consultant Tom Kowalski.
Hello.
And today we have subject matter expert and recurring guest on the podcast, Preston Frazier, who's a senior software engineer from the Interoperability Institute. Welcome back, Preston.
Thanks for having me. Great to be here.
Excellent. So in this episode, we're going to discuss cost optimization strategies, in particular in the serverless context, so with serverless architecture. We've touched on this topic a little bit on a lot of our previous discussions, but I'm hoping we can dig in today and really get some interesting conversation going. So I guess I'll kick things off with you, Tom. As consultants, when we're explaining the cost model for serverless architecture, I see a lot of people fall back on saying you pay for what you use, but you could say the same thing about cloud cost model in general. So, how does that differ from the cost accrued from spinning up a database or a compute instance? Like, if we have actually serverless architecture, how does the cost model compare?
Yeah, I think, the idea moving to the cloud, right, is you're eliminating the undifferentiated heavy lifting, as AWS likes to say. So, you're focusing on the total cost of ownership. Whereas, before you had to worry, half of, a portion of your resources of your company are going towards maintaining servers, and that may not be your bread and butter. Maybe it is, but most businesses, they're focused on something else. They have a different customer value that they're trying to solve for, and it's better if they can just focus on that. So when thinking of serverless, it's just that next evolution in that, right? It's that another abstraction layer where it's less that you have to think about. So yeah, that's kind of how I approach it, right? It's that, it may seem more expensive, right? It is more expensive to run, in a co-location and then, cloud and, now serverless. But if you think about it in that total cost of ownership context, it allows people to see it better, right? Because when they, just think of like a server running and they compare it, apples to apples. Well, if it, runs exactly the same amount, it might be a little bit more. So yeah, thinking about that abstraction and the total cost of ownership, that's how I like to approach it when I'm talking about serverless costs.
Yeah, absolutely. And just to kind of compare a little bit between the different levels of, or different layers of abstraction, you could discuss spinning up an EC2 instance and how that would accrue cost versus running a Lambda in AWS, right? So you could have a gigantic, 4x large EC2 instance that's that you spin up, that's basically running the meter. And if that isn't appropriate for your workload, that's still going to be accruing cost as long as that server's running, right? And as opposed to a Lambda, the Lambda is only going to be accruing cost when it spins up, or the length of time that it spins up. So that said, there is sort of an element of right sizing when it comes to things like Lambda functions, and you can talk about some of the controls there, like concurrency and how much horsepower you put behind it, but which we can get to that a little bit later. But speaking more generally, I'd like to get into some of the examples of common components that contribute to the costs for serverless architecture. So we talked a little bit about compute, but there's some other things as well. But yeah, and I wanted to get some input from you too, Preston, on this. So what cost components like compute that you would typically see in serverless architecture?
Yeah, we've already touched on Lambda is a huge serverless service, but other things like Dynamo DB, a serverless database, you're only charged for when you're running requests against that. I think there is a storage size charge, but I think it's pretty low. Services like SQS, where you're charging for API requests to a serverless queue, or SNS, where you're making message requests, or AWS has something like step functions that help you orchestrate workflows. Those are serverless services that you're only paying for when you use it. So those are some things that are available and to throw on another one, which is popular, is like ECS or Kubernetes, where you're starting up containers and then shutting them down when you're finished with your work.
Right. Yeah, those are all really good ones too. Things like data transfer costs as well. I mean, when you design a network, there's data flowing in and out of that network. Usually for things like AWS and Azure, I think like the data that is transferred within the network doesn't get added to cost, but data going in and out typically does. But these are things to be aware of that do accrue cost within serverless architecture as well. So of these cost components that we just talked about, things that contribute to the overall cost, which ones would you consider to be more difficult for organizations to reduce cost for, and which of these are typically easier? I mean, I know it's going to vary a lot from organization to organization, but do you see like a common thread of things that are more easily to save on cost versus others?
I can start off and say that I think the easiest one is, it all depends on your architecture. I'll be upfront and say that, because there's so many different architectures you can have. And sometimes, a traditional architecture might be better than a serverless architecture, depending on your workflow. But, compute workloads are usually the easiest ones to convert from a traditional server to a serverless technology. Convert something that was running on a EC2 instance, a server, and turn that into a Lambda. So maybe you have an API, a web application or something that you make API requests to. And so instead of having a server that's running 24/7, you have an API gateway and a Lambda function behind that. And so you're only paying for those API requests when people are using your website. So it's, on-demand availability. That's kind of an example of maybe a simple transition from traditional architecture to serverless, is using changing out the compute layer.
Yeah, absolutely. That's a really good example. Do you have any thoughts on that as well, Tom, in terms of like which components might be difficult to reduce the cost for versus others?
Well, so I like to just thinking about it at a little higher level is usually where the cost comes into play. At least that what I've dealt with. It's the people and, the cost of building the solutions, the cost of maintaining them. Like Preston said, the architecture, right? Which, I'm a huge fan of Conway's law, right? How it applies to all architecture. So it really depends on, the organization and how they're set up to build these and handle them. That's where the big cost comes in, that I've always seen when working with various teams and organizations. So those components, when I talk about it, it's how long is it going to take this team to get up to speed on learning this new technology? How often is it going to change? Who's going to be maintaining it? Are they familiar? How often is it going to be updated? Or is this like a set it and forget it thing? There's a lot of factors in there, right? In that architecture that almost make the optimization of the smaller components, I'll say like not worth it, but not as important, right? You could be paying twice as much for serverless, capacity, and maybe it's not architected properly, but it might not be worth it to pay an engineer to re-architect it to be better. So I know you wanted to get into more of like the smaller components, technical side, but yeah, when I've dealt with it, it's that cost. It's like a step higher, right? It's usually the bigger cost. People like to see I saved this much by switching this workload over here or whatever. But that's just what I've seen is more the people side of it.
Yeah, that's a really good observation because, software doesn't build itself yet.
Yeah.
Right. Yeah. And a lot of those are, what people would consider like hidden costs, but having a good standard for how your architecture is designed, built, and then pushed out into the cloud is very important, as you pointed out. I mean, if you don't really have any standards or controls, and people are, building things using infrastructure as code, but then also just kind of like creating one-off lambdas or spinning up random instances outside of that. I mean, that can also accrue cost, and sometimes you won't even know until much, much later when you do an architecture review, and find all of these things that are like, well, what is this being used for? Oh, well, that thing is a jump box that we haven't spun up or used in a long time. So definitely a really good point there.
To go off of that, it's interesting because when you say like the one-off Lambda functions, it's very easy to do that, and that can be a problem. And it does take some discipline to treat serverless solutions and workloads like any other in terms of the port around them. Making sure they have unit tests, the pipeline, right? Good documentation, all of that. It can be easy to just spin something up and get it going, and then it bites you down the line if you don't treat it like a real production service, which it could be.
And off of that, I don't want to jump ahead if we're going to talk about this later, but those serverless architectures, they're not always running, or they only run when you send a request or you need work done. So a lot of times when you're building them, you're not getting the full picture of the cost, because you're not running a production load against your system. So doing load testing in, your development environment is even more important with serverless. So you really are getting the picture of like how much that's going to cost, or how much your service is going to be utilized, because, it's not going to be running a lot of times when it's deployed. It's just sitting there waiting. And load testing can really help you find, cost problems and inefficiencies with your architecture. That's huge.
Right. Yeah. And that is something I've seen before where, people will switch to serverless and they'll go in their dev and test environments and be like, wow, there's so much cost that we saved on this, when they're really not hardly running any kind of heavy load on it. And then when things get to pre-product production, like, whoa, what happened? Right. Well, it's because now we're running production loads. This is the more of what you would expect, right, to see in terms of cost. There's a lot that we discussed here that could be easily overlooked, right?
Yeah. And before I forget, I just want to bring up, as you're mentioning, dev and test environments, right, and saving. I know we've talked about this before, but that's also really the big cost, right, when talking about the components of things that you couldn't do before. Especially moving to the cloud, right? It's easier to do DR. So now you can do it. Maybe you didn't have it before, but no, now it's an extra cost. It's kind of the same with dev and test environments, where now with serverless, you can have those short-lived, ephemeral, spin up an entire production environment, exact copy of production environment minus the data, and, run your workloads, test it just like it would be in production, where as you might not have been able to do that, might have been very cost prohibitive, time prohibitive, to spin up SQL Server cluster. You might not be able to do that, whereas with Dynamo and Lambda you can. So it adds like another element to it, and that's just kind of another thing that I've noticed is, well, people like to just look at that production cost. This is how much it's running. Whereas a huge benefit of serverless is being able to have production like copies, right, for every single branch of your code. And it may actually cost more than it did before, but now you can't, from a just, running those components standpoint, but now you can have so much better quality control when developing. So, yeah.
Yeah, I can attest to that. My organization, we have dev and test environment. It's completely, isolated in its own AWS account. So we definitely know how much we're spending on our dev costs. And so, like you said, with that, we can spin up, shut down our CloudFormation stacks or however your applications are organized on demand. And, along with that, even if you don't want to maybe undeploy all of your resources or remove all of your resources, you can turn off some of your, resources, maybe disable them in like off hours when no one's using them for development. Maybe you don't. In my place, we have a lot of applications deployed and quite a few servers with that. And we don't want to undeploy all of our applications every day, but we can turn off our servers. And so one trick or one, tip we do is we have a scheduler where we can schedule all of our, databases, EC2 instances, anything that's kind of a constantly running server, we can shut that down on a timer, 6 or 7 p.m. after, we're done with work, and then start it back up in the morning, 7 o'clock in the morning, and we're ready to go for the next day. So we can really save, 12 hours of cost for our dev account where no one's doing any dev work.
Yeah, that's a great point. This is like the flip side of it, right? Where you can actually achieve that parity between your lower environments and your upper environments like prod and pre-prod without having to make very many special cases for architecture, right? You can just decide, and it does depend on how you build things out, but you can decide, okay, we're going to be doing a load test during this period of time to simulate a production of a load. Let's see how much this is going to cost. Let's see if we need to right size anything. And yeah, like that can, rather than having a duplicate environment that's pre-prod that would double the cost, right? You would have the same architecture with potentially dramatically reduced cost by comparison. So yeah, that's some really great points all around about that. So yeah, I'm going to now kind of talk a little bit more about some of the best practices. We talked a little bit about serverless functions. And one of the things that I love about serverless functions and how the cost model works for those is that, there's a huge incentive for making your code run efficiently. And how well you can do that and how well you can implement your code to run quicker and faster has a direct impact on how much you're spending, which, it's great that there's that direct correlation. But yeah, just in terms of some common pitfalls that organizations face, like in terms of like inefficient serverless function usage, like I want to get you guys' opinion on like what are some potential pitfalls that people should avoid when it comes to serverless functions.
Sure. Kind of like you said, when you're talking about running a Lambda function and maybe it does one small thing and then it shuts down. Maybe to expand on that, let's say you have an event triggering the Lambda function. Maybe it's a SQS, and you're reading one item at a time from that SQS, and each item is one invocation of the Lambda, and that invocation costs money. But you can change your batch size from SQS to where instead of one item from the queue processing for an invocation of the Lambda, you can process 10 items from the queue in one invocation of the Lambda. So it's really, unique to each of the services, but understanding the full set of features on the service can help you maximize your cost and efficiency. So you really are getting the best value out of, your Lambda function. So instead of invoking the Lambda, 10 individual times, you have it invoked one time and it processes your workload. So that's just one example with Lambda and SQS.
Yeah, so I think what you're getting at is just one of the pitfalls is just leaving all of the different controls and configuration for these as the defaults, right? Which, starting out that way is okay, but if you really want to be able to save on cost, really finding out how to adjust those controls to make things work for the Lambdas you build or for the architecture that you build is going to be really important.
Right. Another thing with Lambda is like, the amount of memory you give your function. You don't need to, sometimes you don't need to give it a lot of memory, you can give it the minimum amount of memory and it'll process your workload just fine, because that memory usage is a cost factor in how much you'll spend per invocation. So the lower you can keep that, the cheaper your function will be. And maybe you can, tune your code or your, workload so you can use the smallest amount of memory possible, increasing your value or, efficiency, cost efficiency for that Lambda.
Yeah. How would you say that businesses could find the right balance between in resource allocation and right sizing, right? So the suggestion that you just said, start really, really small. What would be the deciding factor for deciding to turn it up?
It'll really come down to your testing and maybe back to that load testing to really give it a full production workload to make sure that you're, allocating the proper amount of memory. You'd really hate to get to production and all of a sudden your function's running out of memory. And, that's something you can tweak really easily in the AWS console to fix that. But again, you might not run into those limits in your testing or your development environment without that production volume going through.
Right. Yeah. So we talked a little bit about turning up the memory, or adjusting the memory, I should say, turning up or down as needed. Another one of the controls that I've seen used very effectively are the concurrency controls for things like Lambda functions. I believe you have some experience with that too, Preston. I'd love to hear your thoughts about the concurrency controls and what it allows you to do as a feature for serverless functions.
Yeah, so obviously being able to run multiple Lambdas concurrently is the way to scale out scale horizontally your work, so you can process many things in parallel. So back to that scenario of having a queue with many items in it, you need to process that. You can have your Lambda processing. I think you can have it up to 1,000 SQS invocations from an SQS at a time. I think that's the current limit. I know the actual Lambda limit's higher, but I'm talking about SQS event to Lambda. So if you don't want the maximum there, let's say you don't want to spend that much money to have that much many Lambdas processing concurrently, you can move that number back down. So maybe you're processing, 10, 20, 50, however many items at a time, you want. So maybe your concurrent executions are smaller. And from a cost standpoint, that might not be a big difference, because you're going to use the processing power eventually, either just right at one time concurrently or over a longer period of time. So cost-wise, that might not necessarily be a benefit of changing the number of concurrent executions. But what could be something useful is gearing towards your architecture. Maybe you have 1,000 Lambdas running, and the Lambda does some, network requests, API requests somewhere, and maybe 1,000 connections at one time is going to be too many. Maybe it's going to be overloading a third-party system or another system. And you really only want to have say 100 connections open at a time somewhere. So using that scaling, that throttling might be more useful for architectural needs rather than cost needs.
Right. Excellent. Yeah. So we are kind of coming up on time already. So I just wanted to get everybody's final thoughts and just to get any points in before we conclude that you wanted to bring up. Tom, did you have any final thoughts on cost optimization for serverless architecture?
Yeah. Again, I got to take it up a layer, right? And my advice is don't over-engineer. It depends, right, on your workload. Yeah, maybe it's costing hundreds of thousands of dollars, and it makes sense to optimize for cost. But a lot of workloads, that you're going to make serverless, especially initially for most companies, it's going to be a small workload, right? It's not going to be doing that much. And I've seen it before where, the engineers will hey, we can save, you drastically save money, right? Like, again, magnitudes of scale, but maybe it's only costing, a couple $100 a month. It might not be worth it to have your engineer work for a week on optimizing that. So, which I have seen happen. So, just be careful of that. And like we said before, separating out your workloads into each workload and environment into their own AWS account. So the teams that own them or working on them can see those costs. It's very visible. It's a very good thing to keep it in control. Again, this is where, it can lead to the over engineering, because now they can see those costs. It becomes a game, right? Gamifies it, right? Get as low as I can. So yeah, just be cognizant of that. And, when trying to optimize.
All right. Excellent. And Preston, final thoughts?
Yeah. I mean, I'm probably guilty of trying to over-engineer something. There's a lot of shiny services out there that are really cool. And there's like, oh, wow, I can use this because it's going to give me this visibility into the system. And there's a lot of services that can be useful and can, add a benefit somewhere. But of course, there's always a cost associated with it. And as an engineer, I think it's really important to think about the cost up front. You have to think about the cost up front when you're starting an architecture. Otherwise, you're gonna run into a surprise down the road. I think that's one thing that sometimes we're guilty of as engineers. We think of the services and architecture before the cost, which we got to do those together. And I'd say my biggest important thing, just to go back to it, is making sure you're doing that load testing, that you're really testing your architecture. So it's going to tell you what the cost is going to be before you put it in production, and a month later you have this really big bill and you're really surprised. So test first.
Excellent. Well, I'd like to take this opportunity to thank all of our listeners for tuning in to today's episode of Lunch with Tech Leaders. We hope you found the conversation informative and valuable, as always. We'd love to have you join us again for the next episode. I think we're skipping next week since it's going to be Thanksgiving, but the week after we'll be covering ChatGPT, custom assistants, and agents. As always, the episode will feature expert guests and interactive conversations, so be sure to tune in. Thanks, everybody.